In the previous video, we used the getCookedEnvelopeData node in order to use the envelope data of a character's speech to drive the graphics of that character. The getCookedEnvelopeData node interpolates and averages the data across all playing sound waves on an audio component. But there will sometimes be occasions where you want to extract the data from sound waves individually. For example, you might have a sound cue that is playing several different audio tracks, but you want to use each one to drive a different aspect of the game. In this video, we'll look at how to use the envelope analysis of different music stems to control different particle systems. In the Magic Forest clearing, that's bookmark key 4 of the demonstration level, when you've completed all the magical spells, a spectacular light show begins, or at least a mildly entertaining one. We're going to trigger this using the cheat key Q, so we're going to walk between these two stones in order to do that. There's quite a lot going on here, so we're going to solo some specific parts. If we open up the blueprint, the Magic Cutscene controller, we can see that the number 6 allows us to solo any sound waves containing the text Cutscene Upper, and also hides all the particle systems apart from the melodic percussion ones and the woodwind ones. These arrays of emitters are public variables, so they've been added from the level itself using the picker here. So this time we'll press Q to start the system, but then we'll also press 6 in order to solo the woodwinds and melodic percussion emitters. We've isolated the woodwind and melodic percussion parts since that's what we'll be concentrating on in this video. Hopefully you can see there how the beams were reacting to the envelopes of the individual parts. Going back to the blueprint, you can see that it contains an audio component, and assigned to this component is this sound cue, the Magic Cutscene Music All. This sound cue is comprised of 4 musical layers or stems, and looking at the sound waves themselves, you can see that we've enabled envelope analysis. This means that the engine has stored the envelope data offline, or in other words has cooked it. Having cooked data means it is relatively cheap to access this at runtime, rather than having to do the envelope analysis in real time. We discussed these settings in a previous video, so we won't go over them again now. For the cave fairy in the previous video, we dragged out and got cooked envelope data like this. Now this gives us an average for all sound waves playing on the audio component, but this time we want to access the different parts or stems of the music, using the envelope data of the melodic percussion to affect the blue beams and the envelope of the woodwinds to affect the yellow beams. With the getCookedEnvelopeData for all playing sounds node, this returns an array. The array contains a sound wave envelope data per sound struct. A struct, or structure, is just a special type of variable that allows us to hold a collection of different types of data. The node is being driven by a tick, so each tick or frame of the game, we have a for each loop here that's going to read through that array and give us each element in it. If we add a print string here, we can see that each tick, the array is filled with 4 elements. So you could see that print string down the left hand side. Those 4 elements are the 4 structs that contain the current envelope data for each of the 4 sound waves playing in the sound cue. This all happens very quickly, so let's add a breakpoint which will allow us to step through each operation in turn. So I'm going to right click on this branch and add breakpoint, and as we get each element we're breaking the structs open. So from this sound wave output here I can get the name of each of those sound waves that are playing. So I'm going to watch this string here and see how that correlates to each of the sounds in the sound cue. Okay, so our breakpoint has been activated straight away, and you can see here that we've gone through our array, and the first element we've got out is the struct for the cutscene upper woodwinds. So that's the first sound in our sound cue. We'll then resume, And again, now we've stopped again, we can see that we're now looking at the element that contains the envelope of the upper melodic percussion, then the lower brass, then the lower percussion. We're getting an array of structs that contain the envelope data for our 4 sounds. And then we can go through each struct in turn to use this data to control different things. So I'll now just turn that breakpoint off and stop watching that string value. Looking at the next part of the system, for each operation we check the sound wave reference against a string to see if the sound wave contains this text. For example, the sound wave for the woodwinds is actually called cutscene upper woodwinds, and since it's the only sound that contains the text or string woodwinds, this is the one that's going to set this branch to true and execute the action on that particular data. We could have just used string equals string and used the exact name of the cue, but there may be occasions where you want to group your sound waves using their names and get the data from a particular type that happens to be currently playing. So this contains function, or so-called substring parsing, can be really useful. So now we know that we're looking at the woodwind sound wave, we're taking the associated envelope value that represents the amplitude of the woodwinds at the current time, and we're mapping that to a given range and using this to control the yellow beams within the game. Let's just solo the woodwinds using the keyboard key 2 to take a closer look at what the envelope data is doing. So I'll just switch off that print string, and then let's take a look here. So we've looked at the envelope values and we know that they go from 0 to 0.07, and we're mapping them to the range 0 to 1, which is typically a good starting point. The first thing this is affecting is the color of the beams. We have a variable of type color which has RGB values and an alpha value. Like the sound wave envelope data per sound we just discussed, this color variable is also a structure or struct. We've just exposed each variable within the struct, in this case the 4 byte variables. And we've done this by getting a reference to our struct here, right-clicking, and using split struct pin. Alpha is the transparency setting, and like the other color values it goes from 0 to 255, with 0 being fully transparent and 255 fully opaque. If we find one of the emitters in the viewport, we can open its particle system. Here we can see the parameter we're controlling, which is part of the color over life section, and we've named it beam color. This needs values between 0 and 1. So we're dividing the color variables by 255 to convert them to this range before multiplying them by our envelope value. Moving all the colors between 0 and 1 is moving them between 0 intensity, which is black, and full intensity, which is white. The effect this has on this specific particle system is that the closer you get to black, the more transparent the effect is. We're also using that scaled envelope value to adjust a parameter called beam width and beam length. And again, these relate to parameters within the particle system, within the size scale section, beam width, and within the beam data section, beam length. So on each tick we have this second for each loop that gets all of our beam emitters and applies those parameter changes which are scaled by our envelope value. For the melodic percussion, the approach is very similar. So let's have a look again at these melodic percussion and woodwind stems and their corresponding emitters. So press Q and press 6 to solo those 2 items. In this video, we've seen how we can access the envelope data of individual sounds even when they're playing together on a sound cue. By reading through the array of structs each tick, we're able to break these collections of data and use the names of the sound waves to route their envelope data to different parameters of an in-game object.